All right. I'm trying this for the third time. It's gotten kind of frustrating here, so we'll see what happens. First thing I'm going to do, folks, is I'm going to show you the answers from last night's homework assignment, okay? Feel free to pause here as I go down. Make sure you've got everything correct. Let me just double check that, make sure I've got, oh, there you go. Go back up. There it is, okay. Make sure you've got everything correct. Look over everything carefully. If there's anything that you have questions on or not sure about, let's talk about it, okay? You have to know how to set these trig functions up, sine, cosine, and tangent, and you have to know how to accurately solve for the unknown lengths, okay? So as we scroll down here, again, look over everything. Numbers 18 and 20, the very last two, I have put down the answers over here at the top of the problem and then tried to show the work, okay? For those of you that were not in class yesterday, you need to get with somebody to talk through how to do those problems. I'm going to teach you on Monday how to figure out the measures using your calculator, but I want you to know where they came from and how to use that table there, okay? Now, for today, I gave you this worksheet here, 8-3 review, and we're going to actually look at two problems together. The first problem, I'm going to pull up, I pulled up, let's see here, I think it's, where's that? Right there, okay, is this one right here, okay? And here's what it says. Let me make sure I've got you on the right setting. Yes, I do. Okay. It says this: suppose a zip line is anchored to one corner of a course shaped like a rectangular prism. The other end of the anchor is opposite corners shown. If the zip line makes a 60-degree angle with post AF, find the zip line's length of AD. Okay, we want to find this length right here. How long is that right there? Okay, well, how do we do that? Well, if you notice in that triangle, in that rectangular prism, you have a 30, 60, 90 triangle. And so what I would do is redraw that 30, 60, 90 triangle with everything that we know. So here's the length of AF, 25 feet. Here's my 90-degree angle, and that's the part that goes all the way across there, okay? And then what we want to find is the length of AD, okay? Here's the unknown. Now, remember, we talked about this. Well, the reason why I chose to show you this problem is because there's a lot of dimensions. It's a three-dimensional shape, basically, the rectangular prism. And so I didn't want you to get confused by some of the external details there. Now, if you remember, in your 30, 60, 90 triangle, you have x, 2x, and x radical 3. So what's the length of AD? Well, if x is 25, AD is going to be 50 feet. Okay? So something to just be aware of there. You can figure out that length. Now, the last problem is another one I wanted to go over with you guys, and it's again a trickier problem. For those of you that struggle to see all the dynamics, I would draw the triangle separate. In fact, I think I'm going to do that here real quick. We're going to start with this triangle on the far right-hand side because I know the most information about it. Okay? This is a length of 12, x, and z. Okay? And this is a 30-degree angle. Okay? Now remember, in the 30, 60, 90 triangle, the hypotenuse is 2x, the shorter leg is x, and the longer leg is x radical 3. Okay? So if I'm going to solve for x right here, I'm going to divide both sides by 2, and that means that x is a length of 6. Okay? To get z, this is going to be x radical 3. So if I plug the x in, 6 is x, z is going to be 6 radical 3. Okay? Now, we can tell from the picture right here that y is going to be 10. And if, I think we're making sure, let's see here, it's a trapezoid. Yeah, we're going to say that this is a rectangle here. We'll say that this is 6. Okay? Well, if this is a 45, 45, 90 triangle, remember in a 45, 45, 90 triangle, put that over a bit. You have two side lengths and a hypotenuse. Okay? And so the side lengths are both at 6. So I'm going to say 6 and 6. And if x is 6, what's the hypotenuse? Well, that's going to be 6 radical 2. Okay? So it is asking for, we want x, y, z, and the perimeter of the trapezoid. Oh boy, I almost sneezed. All right. So what's the perimeter? Well, the perimeter is this distance around the whole outside. And this is where I wanted to make sure we got this down, because I think you guys could do all the other parts pretty quickly. It's just this last part. So the perimeter, I'm going to start right here at 6 plus 10 plus 6 radical 3 plus 12 plus 10 plus 6 radical 2. Okay? Now, I'm going to show you how to do this, but I'm going to provide a little analogy here that might help you figure this out. I told you guys earlier that you should treat these radicals like variables, okay? And when I look at this radical and this radical, they're not the same. So they're not going to be the same variable, okay? So if I was to go ahead and figure out what the perimeter is going to be, it would be something like this. 6 plus 10 is 16. Plus 12 is 28, plus 10 is 38. So I would do 38 plus 6x plus 6y, okay? Or 6x plus 6y plus 38, all right? So the same thing is true up here. If I add those up, 16 plus 12, 28, plus 10, 38, plus 6 radical 3, plus 6 radical 2. And that is your perimeter in simplest radical form. You don't want to combine those two, okay? All right, now to finish things off, let's do this. There we go. I want you to go ahead and finish up the rest of the homework there. Let's talk on Monday if you have any questions. If you like I said, if you can't see the diagram very well, go back to Schoology and pull up that PDF. I think you'll be fine. Anyways, I hope you had a great day. We'll see you on Monday. Bye.